Alrighty guys, for number 13, it gives me this equation and it tells me to name all of these different things about it. So this is a very good summary question. Quick side note, I did not have enough time to make all of the videos, so the ones that are, I tried to post my solutions rather than just a key online, so you can try to follow along with my work. If you have questions, I'll be at school at 7 o'clock tomorrow morning. So sorry the videos were not all posted in time. However, this study guide will not be for accuracy because of that, but will instead be for completion. So make sure that you have at least attempted every problem. Another issue is I forgot to bring my graphing calculator home. So what I need to do is I'm going to use the calculator that I have on my computer. So let me pull that up. Give me just a moment. I'm going to plug in this equation into my calculator. So let me see if I can make this work. Because I need to be able to see what the camera is doing. Okay, cool. It's not backwards or anything. All right, so I'm just going to plug in 2x to the fourth minus 12x cubed. Oh, I messed up already. I'm sorry. 2x to the fourth minus 12x cubed minus 70x squared plus 264x plus 160. We're going to look at the graph of that. So the first question asks us what the name of the polynomial is. In terms of the degree, that is going to be a quartic, because my degree, the highest degree is 4. So that's going to leave it as a quartic. Sorry, I'm about to sneeze. Maybe not. So in order to find the zeros, there's two ways we can do that. We can go and press second graph, which will take us to the table. And we can scroll through and look for where y is going to be 0. So if you scroll through, you don't see many. So what we need to do instead is go to the graph. I'm going to zoom out so I can see a little bit more of my picture. So if I had a quartic function, meaning the degree is 4, then I should be looking for 4 zeros. Sometimes you'll have imaginaries, which means you won't be able to see them on here, and you'll have to do the synthetic division as like numbers 1 through 5 on the study guide. But here I do have it crossing that x-axis 4 times. So what I can do is I can go to second trace. I'm looking for my zeros, so it asks me for my left bound. So left bound, I'm looking for when y is about negative 5-ish. All right, so if my leading coefficient was positive and this is even, that means it's going to look like this. If I zoom out a lot, it'll be facing upward. Oh no. It'll be facing upward because it's even. Both of my end behaviors are facing the same way. They're facing up because my leading coefficient is positive. So that means that this is going down, up, down, up. So the left bound will be, it won't be here, it'll have to be up here. So if I scroll 1 to the left, you can't see it anymore, but I have now gotten a positive y value. I need to get a negative y value second because we need that sign change in order to see where the 0 takes place. Asks me to guess, I don't need to guess. So if it says negative 1e to the negative 10, that means that I'm going to go 10 decimal places to the left, and those will all be filled with zeros. So this is actually 0. It's a pixelation issue. So my zeros are at -5, or my zeros exist when x equals -5.1516. I have 2 more zeros to find, so I'll find them the same way. Second trace, I'll find my 0. My left bound is going to be now on the bottom, and I'm looking for my y to be negative, and then for my y to be positive, which means that there was a sign change and it started out negative and became positive. It asks me to guess. I don't need to guess. And I've got another 0 at when x equals -0.537. I have 2 more to find. I'll go to second trace, 0. I'll be looking for a positive y and then a negative y, because now we're coming back down. So these are all positive. Switches to negative. So my left bound is positive, my right bound is negative. And I have another 0 at x equals 3.537. And my final 0, second calc, 0. Now my y is going to be negative, turning positive. So it went from negative to positive here. So this would be my left bound. This is my right bound. Press enter. And x equals 8.16. So that is going to be all of my zeros. I'll go down to my page in a second so you can see what I'm doing on here. Actually, I'll just hold it up here. So far, oh yeah, there we go. It's quartic, and I've written down all my zeros. If I know that my zeros are when y equals 0, really I can just say when x is going to have a y equaling 0 instead of writing all the coordinates. Now it's asking for what type of symmetry. Our even symmetry is going to be either symmetric across the y-axis or none. We can already see that it's not symmetric because the distance from the y-axis to this line is much shorter than the distance from the y-axis to this line. That means there is no symmetry taking place here. It's going to ask us for the relative maximums and minimums, so we are going to need to zoom out in order to see those. We'll need to zoom out again. Actually, I'm going to zoom out, but even if you can't see it, if we know the general shape, going to look something like this, then I know that I'm going to have a minimum here, a maximum here, and a minimum here. So really what I could do is I could go second trace, I could go to minimum, and it asks for the left bound. So what I could do is scroll forever. I'm looking for my x to be about -5 again. So I can see it. I want the minimum to be between here and here because I know that it's going to be somewhere down here. So that's going to be my left bound. I'm going to take my right bound. I can see my y. Here, when we were at x equals like -5, when we were here for our left bound, then my y was -8. Then it became -500, -600, -800, and then it went back to 700, which means the dip already took place. So I can press enter there, and it will tell me my minimum, which is going to be at this point here, -3.424, -3.424, comma, -808. We're going to do the same thing for our other second calc. We're going to do that for our other minimum, but on the way I'm going to do my maximum so I don't have to scroll all over the place. For my left bound maximum, I know my maximum, my relative maximum is going to be between these two. So I can scroll. And you can also see where your y is going to get bigger and then taper off. Here we're at 291, it's getting bigger, 315, bigger, 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 and then it starts getting smaller again. So I can go around that point. I can say starting at 291 up until it goes and comes back down again. That maximum is going to be at 1.5. comma 3.6, I'm sorry, 368.125. That's going to be my only relative maximum, because if we have a shape like this, this will be the only maximum point. These two go to infinity, which is an idea, not a number. So now I'll find my other minimum, which will be down here. Second trace minimum. And again, I can see my y's getting lower and lower. And then they start coming back up again. So I'm going to go to about negative 600. It comes down to negative 800, then goes back up. That's a good place. And now I've got my minimum being at 6.424, comma, negative 808. So I think for right this moment, that could be everything we need from our calculator. I'm going to put us back down. So if we're talking about absolute maxes and mins, in order to have an absolute, we must have an even function, which we do. Our function has an even degree of 4. So this is going to have an absolute minimum. But because both of these have y values at negative 808, that means both of these are actually going to be your absolute min. So both of these points are going to be written right here the same way that our relative minimums were written. Now our interval of increase, if you remember, this is an even degree with a positive leading coefficient. It's going to have this shape to it. So that means it's going to increase from my relative min to my relative max, and then from my relative min to infinity. This is all increasing, and this is all increasing. So this point right here was my relative minimum, which took place where my x was negative 3.424. Remember, when you're talking, oh, I'm sorry, that's not the absolute. This all goes here. So negative 3.424. Remember, if I was going to use a bracket, that means that I know that that is definitely a part that will go increasing. But this turning point, we don't know if that turning point is going to be part of the decrease, a stable, or part of the increase. So we just leave it as a parenthesis. This is not going to be a coordinate. This is going to be part of our domain. So it's going to increase from our x here to the x value of our maximum, which is 1.5. Again, using a parenthesis because we cannot call a turning point increasing, decreasing, or constant. The other part that's going to be an interval of increase is going to be from this minimum, which we have that point already, 6.424, all the way to infinity. Now, if it's increasing from here to here and here to here, it must be decreasing in the other places. So I can say that from negative infinity to negative 3.424, it must be decreasing. And from 1.5 to 6.424, which we know is true because from negative infinity until this point, it will decrease. And then from here to this point will decrease as well. Now, if we have this general shape, then we can look at our end behavior. As x approaches negative infinity, f of x is going to be going towards infinity. It's going up. And we're going to follow it in the same direction we go. If we're going to the left, we're going to follow this to the left. And it goes up. And you can just think of f of x as y, if that helps. And as x approaches infinity, going this way, then we are also going to infinity. So keep in mind that your end behaviors will match when you have an even function, and they will be negative infinity and infinity, not and, it changes depending on the leading coefficient. So for odds, these will be, one will be positive, one will be negative. For evens, they will match.